Okay, so here we go. This is talking about limiting reagents and calculating how much you can make from a reaction if you have varying amounts of chemicals. So, like what a limiting reagent is, all of that. It's really an extension of stoichiometry. So, when I introduce limiting reagents, I always like to start by talking about some fast food lasagna to illustrate the point of limiting reagents. So these gentlemen here from Epic Mealtime, you can go check them out if you don't know Epic Mealtime. This is from well before they had a show on TV. So one day they decided to make some fast food lasagna. If you were wondering what goes into fast food lasagna, there's of course some burgers. And we're going to say that there are 15 burgers in a fast food lasagna. Of course, you need some cheese, right? Like 2 pounds of cheese. You can't forget the onion rings, right? So like, I don't know, six bags of onion rings. And of course, the Big Mac sauce. You know, because we're in chemistry, right, we're going to use metric units. And because they're from Canada, they also used metric units in the video. So 1 liter of Big Mac sauce, right? So all of that, right, makes 1 fast food lasagna. So let's say that instead of 15 burgers, right, you have 45 burgers, right? We got 45 burgers. Instead of 2 pounds of cheese, we have 4 pounds of cheese, right? We were somehow able to get 3 liters of Big Mac sauce. I'm not really sure how that happened, but we were able to come across 3 liters of Big Mac sauce. And of course, we got our 18 bags of onion rings. So, if the crossed out numbers were our original amount that it takes to make 1 fast food lasagna, and the numbers that are not crossed out are our current values, right, for how much we have. If we look across, right, burgers, we could make 3 fast food lasagnas with the amount of burgers that we have. We could make 3 lasagnas with the amount of onion rings we have. We could make 3 lasagnas with the amount of Big Mac sauce we have. But when we get to the cheese, we can only make 2 lasagnas with the new amount of cheese we have, which means that we are limited to the number of lasagnas that we can make by the amount of cheese that we have, right? This limits the number of fast food lasagnas we can make, which means that this is the limiting reagent in our fast food lasagna. So this concept, as strange as it may seem to talk about fast food lasagna in this way, is the idea of limiting reagents. Right? So a limiting reagent in a chemical reaction is the substance that is totally consumed when the reaction is complete. The amount of product formed is therefore limited by this reagent since the reaction cannot continue without it. So any reactant that is not completely consumed, on the other hand, is an excess reagent, right? So that means that there is going to be some left over. Okay, so how you are going to determine your limiting reagent. So we're going to do some stoichiometry. And these are not going to be any different from other stoichiometry calculations, except that when we are finding the limiting reagent, we're going to have to do more than 1 stoichiometry problem to figure out what our limiting reagent is, right? And so just like for regular stoichiometry, when I was labeling things A and B. I'm going to be labeling A and B, except that for limiting reagent problems, there's going to be an A1 and an A2 at least, so that I can keep track of them. So if we look at this reaction, right, we've got sodium oxide and aluminum chloride forming aluminum oxide and sodium chloride, and we have a question: how much sodium chloride can possibly be made with 73.2 grams of sodium oxide and 154.3 grams of aluminum chloride? So in this question, it's telling us what our A1, A2, and B is. So how much sodium chloride can be made? That tells us sodium chloride is our B. Can be made with 73.2 grams of sodium oxide, right, which we will label as A1 just because it's first in the question, and then aluminum chloride, right, which is our A2, simply because it's second in the question. And so then we go through and do stoichiometry just like we would do any other time, right? We go from A, grams of it, we convert to moles in our first step here, right, using the molecular mass of sodium oxide. We have our mole ratio, pulling the numbers from the balanced chemical equation, right, just like our other stoichiometry. And we finish up by converting from moles to our desired units, which in this case is grams, of our B, right, so molecular mass of sodium chloride. And we find that based on that amount of sodium oxide, we can make 138 grams of sodium chloride. So then we're going to go and do this again, except instead of starting with sodium oxide, we're going to start with the amount of aluminum chloride, right? Same process. First step, converting from our unit to moles using the molecular mass of aluminum chloride. Second step, right, the one that's in every stoichiometry, mole ratio. Right, again, the numbers are coming from our balanced chemical equation. And then finish up converting from moles to our desired unit, which you will notice, hopefully, the molecular mass is the same because we are going from our reagents to the same product, right? We want to know how much sodium chloride can possibly be made. So we're going to do this, right, for the same B here, because we're looking at which one of our reactants, right, is limiting. So we have to know how much of our B can be made with both of those reactants. And so in this case, right, we make 202, or about 203 grams. So if we look, the first one, we could only make 138 grams, which means that A1, right, our sodium oxide, is our limiting reagent, right? That is limiting how much sodium chloride we can make. So that is how to figure out which of your reactants is limiting, because it's the one that will make the least amount of what you are trying to make, right? It is limiting how much of your product can be made. So then, to take this a step further, right, if we wanted, we could figure out how much of our excess reagent is left over, right? So remember that in the last problem, we figured out that sodium oxide was limiting, it's our limiting reagent, and then aluminum chloride is going to be in excess, so it is our excess reagent. And for this, we do one more stoichiometry, where we go from limiting, right, to excess, right? So limiting to excess, because we want to figure out, and this is what stoichiometry is going to allow us to do, we want to figure out how much of our excess reagent, right, is equivalent to the amount of our limiting that we started with, right? And so we're just going to go through and do the same thing. We're going to treat it like any other stoichiometry, right? First step, converting from our unit to moles for our limiting reagent. Mole ratio, or the balancing the numbers come from our balanced chemical equation. Then we convert from moles to our desired unit, right? Just like any other time, where we're using the atomic mass of our compounds. And so in the end, what we get is a number that tells us how much of our excess reagent was used up, right? So it's very important that this is how much was used up, because if we want to find out how much is left, we then need to subtract, right? So if you remember, 154.3 is how much aluminum chloride we started with. This is the number we just found, was how much aluminum chloride was used. And so just a simple subtraction to find how much was left over, right? So after this reaction runs, we should have about 50 grams of aluminum chloride left over, right? So that is how to calculate, to find, one, what your limiting reagent is, and then two, how much of your excess reagent you are going to have left over after the reaction finishes, right? So those are limiting reagent calculations. So like I said, the stoichiometry here is no different than the other stoichiometries we've done. It's just that you're doing multiple stoichiometries for the same reaction to figure out, first, what your limiting reagent is, right? Which one is going to cause you to be limited in how much of your product you can make, and then using that information to figure out which or how much of your excess is left over. All right, and I'll just go back and point out one more thing before the video is done. If you notice the molecular masses here, right, for these, and the number here, right, if we go to the next step, you'll notice, starting with the amount of our limiting reagent that we originally had, and the molecular masses of our limiting and our excess reagent, right? So just keep in mind that that is what you are doing. Okay, I will see you back in class, try the practice, and have a great day.